Welcome back again. We now start the first session of the Technical Forum Virtual in 2021. A big hand in advance to Dieter and Thomas, and now I hand over. It's your turn. Thank you.
Ladies and gentlemen, dear friends and colleagues, dear World Money Fair Technical Forum supporters. A very warm welcome to the first virtual session of the 17th Technical Forum. We are very pleased that you are joining us.
Good morning, bonjour, buongiorno, ni hao, ohayo gozaimasu. Dieter and I would have loved to see you on the World Money Fair on the stage, but we also appreciate to have the possibility to be on a virtual mode to communicate with yourself and have the 17th Technical Forum with you together.
The World Money Fair website shows about 400 auditors from 50 countries of all continents have registered, among which are 170 MINs and national authorities. As we will go live with the session twice today, we will probably see the actual number of participants at the end of the first event. Both for us, the organizers and moderators, as well for the presenters, this virtual stage is a new challenge and experience. However, the virtual stage offers us also the chance to establish new contacts, which we are happy to take.
For the first session today, we have 4 presentations. 3 of those 4 presentations are newcomers on the World Money Fair and definitely on the presentation stage. Please also acknowledge that the preparation of those presentations take time, need to be double done, need to be relooked, and we all are very thankful that the 4 presenters have taken the opportunity, even though they had limited time, to prepare their presentations and to be ready for today's presentations.
After the paper of the companies Constitute, Platit, GF Machine Solutions and Spaleck, we will have live Q&A sessions, and you will see the chat function at the bottom of your live stream. You are invited at any time to use this chat function in order to address your questions to the presenters. We will collect the questions and carry out the Q&A session in a live discussion with the speakers at the end of the 4 presentations.
The first presentation, carried out by Christoph Frenz from Constitute, is the start of the first session. Christoph is calling himself a metal former and has collected quite some experience in the mint industry on the circulation coin side as well on the precious metal coin side. He's done some mileage for this presentation, and let's all together see what mileage he has done and whom he has been talking to.
And when we talk about coins, the key issues attractivity, security and public perception are of major importance. The question if coins with a high relief can also be produced at an attractive cost level will hopefully be answered by Christoph in his paper, and we look very much forward to this.
Welcome to the Technical Forum. Today we would like to talk about some R&D results which we have done in the past to measure the relief of a coin. Before starting, I would like to stress some words on the future of cash. Yes, there is a future for cash. And we have asked experts about their opinion.
My opinion is we will still have cash in 20, 50 years, but of course it has not the same importance anymore than it has now. but we still will have cash. We will not go away that fast.
Cash is fast, anonymous and safe. If you look around the world, there are nice coins in Europe, in Africa, as well as in Asia, in Australia, and of course in North America and South America. If you look at a coin, what makes the attractiveness of a coin? To find out, we today went to Switzerland, in Bern. Bern in Switzerland stands for quality. Let us see what the director of the Mint from here says about attractive coins.
If you have a good design, if you can give the people emotion, and then you have sharp edges and you really can see every detail, then a coin is very attractive. This is Markus Flöth. Markus is the head of the Coin National Analysis Center of the German Central Bank, Deutsche Bundesbank. Hi Markus.
Hello Christoph.
Nice meeting you. Markus, we had a common research project on the relief of a coin. Why is the relief of a coin so important?
If you like to have a coin which will be accepted by the public, which will be perfectly matching all vending machines, you need a really tough specification, you need a good visible relief, and this relief is dependent on sharp angles, on sharp corners. If you have a flat relief which is rounded, you can't see it really. Public is not able to detect the counterfeit, so this sharp relief and this edge, which is really important to have the thickness, the diameter of the coin, is one of the main factors of a perfect coin.
Okay, so if you can put it together, what makes the difference between a good relief and a counterfeited relief?
At least 20 tons of pressure as a minting process. If you compare the edge, if you compare the relief, the old one will stay much longer in circulation than the new.
So minting coins in a good quality with a high relief means that it can stay longer in circulation.
For decades long.
For decades long. Okay. Now we have heard experts and their opinion about attractive coins. If you put this together, a good design makes an attractive coin, but only a distinct relief makes a coin valuable and difficult to counterfeit.
Especially the high relief is helping us to be better than the producer of false coins.
Let's come to the next chapter and the question how to measure a relief. Since 4,000 years there are coins, and since 4,000 years we don't know how to measure the relief. But this now is history. But how to measure the relief? Shall we come from bottom up, or shall we come from the top to the lower? We have decided to come from the top to the lower. We have taken the edge. In the edge we have one layer, and from this layer we go down micrometer by micrometer, that we can distinguish whether we have a good minted coin or whether we have an unfit coin. The left one has to be taken out of circulation?
We do.
Yes. You will sort them out?
We will sort them out because of many other things.
Which one of those two is more economical?
In the end, the right one, because it will last longer in circulation. they will be much more safer against counterfeiting. And yeah, it's a perfect coin.
Thank you, Markus, for the insights, and we look forward to our next research project.
Good.
We can measure the relief, we can distinguish the relief, and we also can say whether a coin is original, counterfeited, or unfit. We have developed histograms, and the histograms can show this is a genuine coin, whereas another one is either unfit or, in this case, without plateaus in between. This is a counterfeited coin, although the coin itself looks good. So we have seen we can not only measure a relief, we also can say whether a coin is counterfeited or unfit or genuine. So the relief of a coin can be measured. You can generate objective data about the quality of the coin, and you can put those data to specifications. So if you want to have an attractive coin and you buy it from another mint, you can objectively say whether the coin is good or not. Besides this, you can have new security features which can be inspected by 3D optoelectronic measurement. But this will be the topic of next year's technical forum. And now you will think, high relief, sharp edges, your die life will go down. We had mints, partnering mints, and they made tests. And they could improve the processes, they could improve the coin design, the flanks, the radius, and at the end they had sharper edges and higher reliefs with a high die life. Let's hear what Marius Haldeman, the director from Swiss Mint, says about their findings for the die life.
By producing this technology, producing coins on this quality level, I'm pretty sure your die life will be low.
To have very good die life, for instance, the 5 Rocken, even though we also have high relief on our smallest coin, we are producing 1 million up to 1.5 million with one pair of dies.
Okay, wow.
From my point of view, definitely, because when you have sharp edges, it's also design is pushing up, and so it's clear, it's straight lines, and so it's more it's definitely more attractive than when you just have rounded corners, and so this looks not so nice, I would say.
Thank you very much, Marius.
Now we have heard Marius Haldeman. Marius Haldeman said you can produce attractive coins with high relief, with sharp edges, and still you have a high die life. High die life, but how to make this? If you are looking at the production of a coin, from casting to packing, then there are 3 important things. That's the blank, it's the die, and it's the process of minting. A high die life and a high relief is possible. We are looking forward to seeing you at the next technical forum in 2022. And seeing you in between would be even nicer. Thank you for your attention. Bye.
Christoph, on behalf of the audience, I need to do this. This is typically the behavior of the audience after somebody has done all the preparation and has taken the effort. Thank you, Marius. Thank you, Markus, for being part of this presentation. And it seems that when you talk about attractiveness, at the same time, you're also involving the security and trying to make coins not only as attractive but secure as well. We've heard partially comments from Marius Haldimann about the productivity, and I'm sure later on there might be question about the cost ratings and the cost level of how to produce attractive coins with a high relief. This is the reminder also for the audience to be part of the chat community and to start communicating, raising questions which we will then later answer and forward to Christoph directly live in the Q&A session.
Thank you, Thomas. A few sentences before we introduce the next presentation of Platit. You all know that the state mints worldwide are located in the big cities or even in the capitals of their countries. In order to make the lifetime of the coining dice economical, hard chroming equipment was used exclusively over many years, and we all know that for environmental aspects, hard chroming is not the best solution. For the first time at the Technical Forum, the company Platit presents with the SM-Pulse line a new state-of-the-art in-house PVD coating system for coining dice. Dr. Juri Vers will introduce us to this technology and submit solutions for the production of coining dice. Juri, the virtual stage is yours.
Hello, and welcome to the first session of the Technical Forum of the World Money Fair 2021. My name is Juri Vers, I'm with Platit Switzerland, and today it's my great pleasure to introduce to you the Platit SM-Pulse, our brand new state-of-the-art in-house PVD coating system dedicated to coin stamps. And before I'm actually going to show you the Platit SM-Pulse, let's consider what is important when we speak about PVD coatings on coin stamps. Well, if you look at a coin stamp, the first thing that really strikes is the tremendous surface quality. We have mirror polished areas with roughnesses in the order of a few hundred nanometers. And within the same stamp, we see micro patterned areas where we have roughnesses in the order of several thousand, yes, even up to several 10,000s of nanometers. That's more than one order of magnitude difference in surface roughness. And with the Platit SM-Pulse, we are able to perfectly replicate and copy this surface with a 2.5 micrometer thin chromium nitride layer. But the coin stamp is not only a pretty surface. Ultimately, the coin stamp is a tool, and the tool needs to perform well. Hence, we can assure you that the PVD coatings from the Platit SM-Pulse have the perfect adhesion to your coin stamp surface, as well as maximum durability within your stamping application. And in fact, PVD coatings are environmentally friendly as they work without any harmful substances and chemicals. So you do not have to worry about hexavalent chromium when you think about PVD coatings. But let me show you the SM-Pulse now. The SM-Pulse is our new custom designed coating solution for coin stamps. It produces high quality sputter coatings, and we have multiple coatings available for you. Chromium nitride, titanium diboride is a purely ceramic coating, carbon-based coatings, and of course we develop specific coatings upon customer request. All coatings are free of hexavalent chromium. You can coat high volumes in this unit. It is capable of coating up to 18 punches within a single batch, which guarantees you a very good productivity. It's easy to use, and when we designed the machine, we paid special attention to its modularity, because maybe you sit in a modern facility where you have big gates where even trucks can drive in and out, then it's no problem. However, if you sit in an old, historically significant facility where you have narrow hallways and small staircases, you will also be able to fit this machine in there. You may think now, wow, that sounds really good, and I know exactly how I'm going to integrate this machine in my existing periphery. Well, that's great for us. We only sell you the machine as a standalone unit and we're happy. However, if you say, wow, this sounds really interesting, but I have absolutely no clue what else I'm going to need to do PVD coating in-house. Well, That's where the Platit turnkey system as a concept comes in, as we can supply the PVD coating unit as a centerpiece of the turnkey system. However, we can also supply the right decoating equipment, cleaning equipment, quality control, as well as all the necessary PVD accessories to get you up and running within a very short time. We take care of your entire process, and we do this since more than 25 years. I mentioned earlier that the S-Impulse is easy to handle, and well, in fact, it really is. I'm going to show you this by the example of how you load coin stamps into the chamber. When you open the vacuum chamber, the first and basically the only thing you see is the centrally mounted sample holding disc. We have standard holders with predefined hole diameters, but of course we also manufacture specific holders upon your request. You take your cleaned coin stamp and insert it into the sample holder as it's depicted on the picture on the lower right. You can load stamps with different diameters within one batch. That's absolutely no problem. The only thing you need to take care about is that the level of the area you want to coat is approximately the same for all your stamps. So if you have a very large or long stamp, you may want to put a spacer ring above. Don't worry, we also supply you with these. Then you're basically finished with loading your tools. All what's left to do now is close the vacuum chamber and press the start button. And how one of the recipe works, I'm going to show you by the example of a chromium nitride. And I'm not going through the details of every recipe step. I'm going to break it down for you into 4 simple basic steps. Step number 1 is pumping and heating. The chamber is evacuated and heated up to a temperature of approximately 200 to 240 degrees Celsius. This temperature is feasible for the majority of steel grains that are used for coin stamps. However, if you use different steels or have different temperature requirements, talk to us. We can take care of that. The pumping and heating step takes approximately 60 minutes, which is then followed by a very important step, the so-called plasma cleaning. After engrazing your coin stamp, cleaning it, and then loading it into the vacuum chamber, a very thin native oxide layer has formed on the surface. In order to ensure that we have the perfect bonding between the nitride coating and your coin stamp, we need to remove this oxide layer. This happens in a very gentle but effective etching process, which takes approximately 35 minutes. And then you're good to coat your specimen. The coating step takes only 40 minutes. In less than 40 minutes, you're coating 2.5 micrometers of chromium nitride. For a PVD process, this is really, really fast. And now your coin stamps are basically finished. All what's left now is to cool back down to ambient temperatures, open the vacuum chamber, and take out your perfectly coated coin stamps. The whole batch time, door to door, takes less than 4 hours. This means that within one day, you can coat up to 4 to 6 batches. This is really good productivity, considering that you can load up to 18 punches in one single batch. Or in other words, after 4 hours, you have your perfectly coated stamp in hand, ready for production. Time is actually money here. And since I cannot stress the surface quality enough, let me show an example of how good the surface qualities of coatings from the S-Impulse are. Here in the back, you see a steel plate which has received 3 different surface treatments. On the very left, we have a finely sanded surface with emery paper. In the middle, we have an electro-erosion textured surface. And on the far right, you see a surface which has been mirror finished with diamond paste. We use the confocal microscope to measure the surface roughness in a relatively large area, 250 by 250 micrometers, on every of those segments. Then we took the steel plate, put it in the S-Impulse, and coated it with 2.5 micrometers of chromium nitride. And then, after the coating was finished, we took the plate out and measured again. And what you can see here is that you have literally no difference from before the coating to after coating, meaning that we form the perfect copy of your surface without disturbing it, without harming it, without any distortion. And with this, I'm already at the end of my presentation. I introduced to you the Platit S-Impulse, our new custom designed coating solution for coin stamps, which is easy to use, fast, provides really excellent surface quality, and the PVD coatings are environmentally friendly and sustainable. You can buy the SM Pulse as a standalone unit, or if you want, as an entire turnkey system, complete with cleaning solutions, decoating solutions, as well as quality control. With this, I would like to thank you for your time, and I hope to answer all your questions in the Q&A session. Thank you and have a great day. Bye-bye.
Yuri, thank you very much for your contribution. Now we all know more about the in-house PVD coating process, and we are curious about the questions from the audience in the later Q&A session after the fourth paper. And for this, ladies and gentlemen, dear friends and colleagues, we really need your active support. We have right now 105 participants online watching this session of the first technical forum. 105 people, this is an amazing number for us. And we need your active participation in a way that you use the chat function below the live stream. You will find that, and you can ask the questions for the later discussions after the fourth presentation. So please use the chat function, ask the questions right away after or during the presentation, that we collect the questions and we will have them available after the fourth presentation for a discussion with all the presenters live. Thank you. Thomas.
Thanks, Dieter. Raise your questions, write them down. Don't be shy, be active in this first virtual technical forum. We will stay within the tool section. We will talk about laser. And interestingly, I think we have had innovative laser technology as a headline since many years. But it's interesting how far laser technology can go. And I think in most of the cases when we talk about innovative laser technology, it is about the precision. I'm not sure whether laser technology has been landing on Mars now and whether it's been used there, but with the preciseness, I think we are going always a step ahead. GF machining solutions. In this case presented by Benjamin and Fred. Benjamin has collected almost 3 decades of experience. Sorry, Benjamin, you are not old. And Fred is the head of the marketing. Both of them have been preparing a presentation and are ready now to explain us the details of their innovation at a micron level.
Good morning, my name is Benjamin Paganelli. I am Head of Sales Advanced Manufacturing Region Europe and South America. Due to COVID-19 restriction, I will wear my mask and let Fred introduce himself.
Hello, I am Fred Goudard. I'm Product Manager Marketing for the laser technology. And today we are going to spend a couple of minutes to speak about the new solution from the group Georg Fischer, the Laser P400 GF Femto Flexipulse. First of all, let's talk about GF. GF is a worldwide group installed all over the world. We are present in the industrial machine tool manufacturing, and we are providing solutions in several segments of application. Can be aeronautic, can be ICT, can be, mold making. We are present all over the world, and we have a network of support huge. So let's start to speak about what we are doing with this machine. So Benjamin, let's show us the type of parts that we are able to achieve with this solution with the Laser P400 GF Femto Flexipulse.
Okay, Fred, thank you for your introduction. So let's start from our first example. Our first example, it's a laser engraving, a 3D engraving on steel. This steel gives us the possibility to explain and to share with you the great details reproduction we can achieve with our technology, and we will come back to the explanation afterwards, and especially how many kind of surface finishing we can achieve with our technology. So this is a steel K390.
What are the challenges with this type of machining?
The challenge is to repeat a 3D details file. So the first topic is how to achieve a great detailed reproduction of the material. And the second is the hardness of the material for sure, because not all lasers are able or allow to engrave such kind of material easily.
You mean that in our solution, we're able to either machine hard metal as fragile metal?
Correct, correct. So we will share with all of you an example about fragile material, but the second example, to come back to the, I will say, the hardness of the material, is to share with you the same file with the same hardware, so the same laser machine on carbide. This example explains a little bit our flexibility to manage different material and achieve absolutely great result in terms of details and especially surface finishing.
And here again, it's with the same unique
hardware.
Machine.
Yes,
same hardware, and we have some features which permit to switch from hard metal to steel, or now we are going to see with fragile
material, yes. Just as we could not be present with all of you in Berlin, we can only share example and not our machine. So this example is just to highlight also our capability to engrave different and exotic material. So this is to open your ideas or your variety of material you could achieve with our machine. And is a perfect example on how our femto green laser could achieve result without cracking the material.
Yeah, because I understood that machining this type of material, you need to have a particular beam which is not going to destroy the material.
Correct.
To avoid to have, remelted surfaces, or to have some, crack on the edge of the details.
Correct. So these open possibilities to engrave exotic material, like for example diamond, plastics, or other material, glass. So we allow you really to open new possibilities with our machine.
So let's talk about our machine. If we come back to the solution that we are providing, it's a machine unique, equipped with two different wavelengths, but easily with an easy operation.
Correct. Our machine is a P400U. We introduced this machine on the market in 2015. We started with 5-axis capabilities machine into the industrial business, and recently we improved the machine by following the market request of our customer. We introduced with our new laser solution with the possibility to manage two different wavelengths. We will come back later to this example. Now I want to explain to our guest why GF is different in terms of machine. So the first, I will say, example to share with our customers is to explain that GF started laser business in 2010 with what we call the laser texturing 5-axis machining. So to explain this example, I have also here the possibility to have a machine, but we will share an example. This is a typical example of a 5-axis laser texturing application.
And here we can see that the texture applied is geometrical. And means that we are able to reproduce geometrical or artistical details.
Exactly. During the software explanation, it will be more easy to understand for you why we use different ways to use the 3D file for the meat industry. The second application we are recognized on the market is to realize laser blasting or laser frosting on 5-axis. Also here, you can see that absolutely this shape is not easy to be lasering, also to be milled, to be honest. So you can see our capabilities to laser blasting or to laser frosting a part.
And when we are able to do that on a 5-axis part, we are able to do that?
I will say it's an easy game for us to do it in 3-axis.
Okay.
The last and the important information I would like to explain to our guest is our 5-axis engraving capability. So you can see it's not easy maybe because it's more easy to do it live with you in Berlin, but you have a 5-axis engraving example. So we are able with a 3D file to apply laser texturing, frosting, engraving, and some also other effect.
A quite complex solution.
Absolutely. About the machine itself, we talk about a 5-axis. We talk about the possibility to engrave different capabilities on our machine. It's important to remain and to remember that we are introducing also some hardware to help our job. The first hardware is to integrate an automatic vision system. So this, especially on the mint industry, is really well used to engrave, also to blast or to frost after milling or other processes. The second is to use a 3D touch probe to adjust the part in the machine itself. This is our standard since many years, also not only for the legs there. And at least, and I take this example, Fred, I think we can easily explain, is how to integrate a job into our machine, because we will come back to the explanation on the software side. The software is offline, so you should prepare your job before. Then when the file is ready, you go to the machine and you do the job. How to make sure that we are in the good position in the machine itself.
It's all the system that you have told us before,
Exactly.
the optical vision system, the probe, which permit to automatically localize the part inside the working area.
Perfect. So in the machine, you can find a chuck like this one. System 3R is part of our group. With each chuck, you can easily come back to the position inside the machine and be ready to job and to engrave.
Cool, cool. And we have some solution of automation if we are producing a large amount of parts.
Yes, absolutely. Automation, the machine is ready to automate, to receive automation. We have different solutions also here, Fred.
Yeah.
We can use and move pallets to be integrated in the chuck.
Yeah.
Or recently, we also move really deeper in the parts production world. Parts production means we have a pick-and-place system who allow us to put the part on the machine.
And here, the tremendous advantage is the fact that with pick and place, we can work on a different population of parts on the same batch of production. Can be different diameter, different morphology of the parts. So it means we have a complete solution for a full automated process.
Correct. And just to highlight also why I talk about the vision system, we talk about parts production, the 3D touch probe sometimes is not, I would say, the best tool to adjust the position of the job compared to the position of the part. So the vision system is absolutely unique to introduce the position of the small part into our machine.
So thank you for all these details. And if we speak about the machine, and we were talking about the wavelengths. Wavelengths provide us, in fact, different type of beam size.
Correct. So before to go deeper on the laser itself, just come back to a short explanation about the software. And it's important to explain to our guests. So you should remember that you could import in our machine different files. Thanks to the partnership with Carveco, today we allow ourselves to receive also files dedicated to the mint industry. So what then we should apply and how we work? An easy way, I will say, we have two possibilities. We can take the 3D file and move directly to our software called LaserCam. LaserCam allows us to bring some details from the 3D file and work on 3 axes directly on the coin. The second, and this is something new for the mint, is to switch and to, I would say, change the details image from a 3D file to a bitmap. This is automatically done by our software. It's done since many years as we started in this business. And the operation makes the job easily and make more, I would say, simple the operation to apply this file into a 3D shape. So I could not, and we could not go details now, but we really ask our guests to contact us later on, and we will go deeper on this explanation.
And one thing that you must keep in mind is that our solution of preparation of the job can be done on a desk, far from the machine, and can be transferred to the machine and automatically set up in the way to produce.
Yes.
Means you don't need to be in front of the machine to prepare the job.
Absolutely, absolutely. Now we can go a little bit deeper to the laser sources, maybe.
Yes,
So
we were talking about the size of the beam.
yes.
It's something very important in a particular environment, because here we are working in the reproducibility of fine details, and usually the size of a beam, it's about a couple of microns. Huh?
Correct, correct. I would say the wavelengths, so we repeat, the laser allow us to use in the same laser sources 2 wavelengths. In the wavelengths identifies the type of material and especially what we can do, which kind of material we can work. So the infrared solution is working with the wavelengths of approximately 1060 nanometer. The power of the laser is a femto laser is 40 watts, so it's absolutely increasing compared to the past. And the green cut by 2 everything. Means we cut the wavelength by 2, so 560 or 550 nanometer. The power also, so we cut by 2, 22 watts. So these allow us to be really efficient in a fragile material like sapphire, for example. And last point is the beam. The femto infrared have a beam approximately of 30 micron with a small focal length we have on the market. But with a green, you could achieve something between 10 to 15.
Means that we have a tool about a couple of microns in the way to reproduce the detail, which is amazing. Huh?
Amazing, amazing.
Nice.
So we thank you for your attention, and we really wait your request, and more than welcome to contact us directly.
Thank you very much, and have a nice end of day.
Dear Benjamin, dear Fred, thank you very much. I really liked your own enthusiasm about the technical aspects you were talking about, the different lasers being used. I'm saying carefully at the same time or one after the other. The technology you're offering. I think I've seen laser technology for a long, long time, and I'm always surprised how much more detailed lasers can work and what kind of preciseness they're offering. I am sure there will be a number of questions from people who do understand much more about the laser technology than I do. So a round of applause for the preparation and the work you have done and the presentation you have established for us. This is also the right time to remember the audience that you can like the questions which are published and which are raised now, so that they climb up in their importance and that they can be questioned or raised first. We have some questions from Europe so far. Asia is a little bit shy, and also nothing from Australia yet. So Australians, where are you? Dieter.
Australians are down under, yeah. But let's see whether we will find Robert later in the Q&A session, as he usually does in the live sessions in Berlin. Now, when we talk about the survey's finishing process, dear friends and colleagues, not only the effective and proof machines are the key of success. The success strategy is completed also by finishing media, which are used in the finishing process. Ingo Löken carried out a study, and we are happy that he will now present us the results of this study, and all MINS and blank manufacturers are surely curious about it. Ingo, the stage is yours.
Hello. Today I would like to talk to you about the way how to strike a very good and very nice coin. I think one of the basic requirements to start with is to please the old desire to have the right blank ready for the striking process. This has been discussed many, many times, and we need to do the finishing operation because from the previous processes like rolling and rimming, there are marks on the surface and also oxides due to material corrosion, respectively. Also, some contamination can't be avoided. This is the role of the finishing process, to create a bright metal surface, to have this clean metal structure to be ready to provide the perfect coin after the striking process. We recently introduced a new type of material into the minting industry, which is a high-performance ceramic. We call that type CHD media. CHD media is also available in different shapes, for example, a 3mm ball, but also in a more robust form, which is, for example, a roller, a cylinder with a diameter of 5mm and a length of 5mm. We did an extensive trial program comparing the stainless steel golden standard finishing media with this new generation of finishing materials and compared them onto one blank type. Actually, it has been two blank types. Kindly, our friends from the Bull Mint have provided sterling silver and fine silver blanks, all from the same lot, all produced in the same way to have comparable results by applying the different medias to these batches of coin blanks. The finishing trials have been done in our demonstration center, which I introduce now to you. So, all the trials have been performed in our technical demonstration center in our factory in Bocholt, and we used one of our centrifugal finishing machines called Z4. It has a working bowl volume of about 25 liters, and we used always the same parameters to treat the different blanks from the different trial setups. We always started with a small pickling step, then went into the polishing phase, and finally applied rinsing to remove the residues from the compound before we separated the media from the blanks. The total process time was always 30 minutes. Afterwards, we dried them with a textile dryer and started to analyze the blank quality. So, here are the results of the surface measurement of the sterling silver. You see the different measurements depend on the different media mixtures, which are a result of the weight and also of the geometry of the media. For sure, more heavy media like satellites or the pins in combination with the edges of these media are generating a more structured surface, which having a higher RZ value than smaller, lighter media like the balls, for example, stainless or ceramic. As mentioned, we want to eliminate especially the rolling marks, which are visible here on the photo and also on the microscope, and that can be generated very efficiently by the stainless steel satellites, which are removing the structure from the rolling marks and also are capable to hide little scratches from the surface. Finally, you create kind of an orange peel, which is also promoting the material flow during the striking process. A similar effect you can also create with a CHD media. Here we are using balls to again break the texture from the rolling and generate a bright surface. Because we do not have the rim, the appearance of the blank having more brightness and are more shiny, because the balls are rolling on the surface instead of ripping off the oxides. After the sterling silver, we also analyzed the fine silver, which is a softer material. Here you see a similar order of different surface roughnesses, again as a function of the weight and the geometry. To treat fine silver, the raw material, with satellites is a bit too rough, so typically you start with stainless steel balls. which here giving the desired result. If you compare this to the CHD, the ceramic media, you get a similar surface roughness, but because the CHD balls are 20% lighter, it's about 4 kilogram per liter instead of stainless steel 5 kilogram per liter, you generate a bit brighter, more shinier surface. If you have more oxides on the surface or little scratches from the rimming process or other storage or transportation effects, sometimes you want to hide these and to want to create also as to promote the material flow for the relief. You want to have a little bit more force of the CHD media. In order to do this, you can use the pins. The pins are having more weight and also having the edges which are similar to the satellites, and this is generating kind of an orange peel similar to the satellites what we know from the past. But all of the results from the blanks are regardless. Finally, what we need to assess are the striking results out of that surface preparation. This has not been done in our demonstration center. Here, for that reason, we are flying to Bulgaria, to our friends from the Bull Mint. Thank you again for Vladimir and Plummer and his team to supporting us with the striking trials. The striking has been done on a press with 180 tons press force, and it has been a 4 times stroke in order to form this lovely design from reverse and obverse side. So we had a close look to the results of the striking. First, we analyzed the sterling silver prepared by the satellites. Very good quality, proof level, but when you go really into the details, you see little dents created by that textured surface from the satellites. This can be avoided by using the CHD balls. Here we have the same clear, bright design and appearance of the coin with no defects, and on top we also have no marks or visible textures in the table of the metal. Going to the fine silver, here we did not use the satellites because of their aggressivity. We used the stainless steel balls in that example. Also achieved proof quality level in the striking process, and a similar or comparable result with the CHD balls. But even in order, like I said earlier, when you have a bit more oxidized blanks, or if you want to hide little scratches on the surface, you can even increase the aggressivity of the media mixture by adding the pins, and that's the mixture of the pins and the balls. And here you, even because you had more aggressive media, you can't find the same structure or leftovers from the satellites what you would likely see with stainless steel media. So striking, quite pleased to see these results, but what about chemical behavior? Here we have to look into the different compositions of the different medias used in the minting industry. To compare these, we exposed 3 different types to a very strong pickling acid, which is not quite common, but still used in the industry, just to demonstrate the resistance against strong pickling agents. The first material we applied that acid was stainless steel grade with a lower quality, just 316, which is not common, but still some people use it, and with the results what we see here, that the strong acid is terribly attacking the surface and is basically destroying the material after a very, very short period of time. A higher chemical resistance has a 316L, which is more the standard in the industry since many, many years. But even there, you see that the strong pickling agent having an effect on the surface, it is forming the bright, shiny surface into a dull texture, and that is reflecting that particles and ions and metal has been solved from the surface of that material type. You can't see any evidence of chemical attack on the CHD media material, which is not a big surprise because from a chemical point of view, ceramics are in general very chemical inert. So, as a conclusion, I have to say Nele is right.
Thank you, Ingo. To summarize, the new CHD media family is offering various shapes and geometries. You can mix that media in different relations. The result is a homogeneous texture of the surface in combination with strong and chemical resistance, finally leading into excellent striking results. Thank you.
Thank you very much indeed, Ingo, for your presentation. This paper clearly shows that this testing period and all good efforts are leading to a perfect surfaces. And as supposed before, it was clear that Nele was right. Ladies and gentlemen, dear friends and colleagues, we have 110 people online, and we look very much forward now to the questions in the now following Q&A session. If not done already, you, dear auditors, now have the possibility to pose your questions via the chat function just below your live stream. Thomas?
Thanks, presenters. This is the right time now to involve the presenters and the owner of the presentations carrying also the knowledge. So we will have them now live. Unfortunately, we don't have them with us, but we will be able to raise all the questions and have most probably very professional answers from them directly. Dieter, would you start with the first question?
Yes, pleasure. I just click it on, and it is for Yuri, for Platit, the first questions. The question reflects, of course, your the option of the decoding system, and how does the decoding system work? Is this decoding system environmental friendly as your PVD system, Yuri?
Well, first of all, thank you for the numerous questions which I can see here. I'm
Yuri,
very surprised that you have so many questions now. In fact, when you decode...
Yuri, we can't hear you.
You can't hear me? That's not good.
Ich kann dich hören.
So other guys in the session can hear me. My microphone is switched on.
We can hear you. I can hear you, Benjamin.
Okay.
Okay.
Now it's working.
Right.
It's working now? Good.
Yes,
okay.
Yes, sorry.
Okay, so again, thank you for the questions. Well, in the decoding process, you, at least if you're dealing with chromium-based coatings, you're of course not free of processes that produce hexavalent chromium. However, if you do a chemical decoding, you have to keep in mind that the amount of chemicals and the amount of coating in terms of volume you're dealing with, it's really, really small in comparison to when you have a chemical plating process, meaning that you're producing chromium-6 in the decoding, but not much in terms of volume. The baths are small, the baths are covered. We take care that you're not getting in contact with any of the chemicals. And this is the most we can do to protect you.
Thanks,
and it's of course always a chemical process. It's not a plasma process for the decoding.
So a clear chemical process, and of course you have to take care of all the byproducts or all the process itself in a special way. And of course, thanks for answering this question, Yuri. Thomas, would
Yeah.
you?
Yuri, there's another question for you, but to get also the other people being warmed up, I raised the next question to Benjamin. That's a question which is raised from Alexander from Axis. You may know him quite well. Any experience if 5-axis engraving will negatively influence high force embossing because of undercuts?
It's absolutely a good question. So we try to explain our software process. So since we started with this technology in 2010, we were asked by our customer to laser texture or laser engrave 3D shapes. So in order to avoid undercuts and to avoid any mistake in terms of embossing or injection or blow molding application, we can, with our file, decrease the level of pixels, so the resolution on the border of the molds, to ensure a proper process during the injection or the embossing. So I would say, by a software point of view, we manage the decrease of the resolution on the border. So we are not affected by any undercut situation.
Thank you, Benjamin. Unfortunately, now we are not operating on a mic, so Alexander has not been able to react immediately, but I'm sure this will have at least highlighted the solution available to him and also to your customers.
Yes.
Peter?
Thank you.
Again, for you, Yuri, the question for Platit: how can Platit apply co-sputtering or multi-layer sputtering with their S-Impulse system?
So when we developed the S-Impulse system, we paid most attention of simplicity of the system. And in this case, it means that we also have only one target in the machine. So if you want to do multi-layer sputtering, you can of course always think about doing a nitride, not nitride multi-layer. This is one option you have. And of course, there are not only targets which consist out of one metal, but also composite targets where you can have different alloys. So this is an option, but we have only one target in the chamber. So you cannot mix individual elements as it just comes to your mind.
Thank you, Yuri, for the clear reply. Thomas, will you take the next one?
Yes, I will. I'm actually not sure whether I have deleted one question, because I wanted the one which was answered to delete from Benjamin. So if you have followed that I've deleted a question which was not raised, please just put it again onto the screen, ask it again. So we are making sure that there's nothing left out. So I've not done that on purpose. I will raise the next one. There's another one for Benjamin. We will raise that soon, but I'm now talking to Christoph from Robert Newman for Constitute. When you look at high reliefs with straight edges, do you see that more complex relief designs are possible with high relief over low reliefs?
Yes, absolutely. I like the question because in the past years, the relief quality...
Wir können Christoph nicht hören.
Yes, I can hear you well.
Perfect, Christoph, now.
Oh, okay. So thank you for the question. I like the question because, yes, it is possible to have two different levels of relief. The system that we have developed even allows to do more different levels of reliefs in the coin, so that there is a more plastical, that there is a more three-dimension experience on the coin. How to do this? That would be an extra session.
Thank you, Christoph. It sounds like you are having another presentation very soon. Dieter, are you raising the next question?
Yes, for GF Machine Solutions, another question from a laser expert. For GF, the cycle time seemed quite high for Femto. What slice thickness did you use for the engraving on the Femto red laser? Benjamin?
So the examples we shown were done with our files. So we tried to get the best profit on that. You should remember that our target to realize such a test was first of all to achieve the best surface quality, I mean in terms of array, and to copy as much as possible fine details. So the target was not to improve the cycle time. By the way, we achieve a 0.2 RA on the surface, and in terms of speed, I could not share the details in terms of parameter, but for sure the improvement could be really huge as we are talking about a 40 watt femto laser system. So the time could be for sure improved, but will be a compromise between the quality and the details we could achieve.
Thanks, Benjamin.
Welcome.
Thomas, would you take the next one?
Yes, Ingo, warm up for you. I know this is not straight to the way they occurred here, but Ingo, to get a warm up for yourself. Ingo, what do you suggest according to your study? What kind of shape, material for irregular shaped blanks? And that question is raised from Simovic, which means Poland is also part of the virtual technical forum today. Hello, Simovic. Thanks, Ingo, for taking this question.
Yeah, thank you, Thomas. Thank you, Simovic, for the question. In order to reach corners and edges of irregular shaped blanks, we are about to launch a different shape, a further shape, which is a ceramic satellite, which has exactly the same geometry like the SHD satellites 5 by 7 millimeter, which you can see here in my camera. So this is the next product we will launching, especially to reach difficult areas, to clean them from oxides and any contaminations.
Thank you, Ingo. Thank you very much. This was a clear answer as a yes, can be used in the future. Ceramic is the way to go. Dieter, are you going?
I'm going to the next one, and as you're messing up the direction of the number of questions, I just have noticed that Canada is online as well, and that's an early morning for Shen Yao. But we will come back to his question, of course, at a later date when we go in the direction we follow with GF machine solutions, because this question also have been very much liked. Are the shown samples produced with the green laser? Is this one of the reasons why the process took so long?
No. So the test we did on the carbide and on the steel 290 were achieved with the infrared system. The one we used with the green was for the sapphire, and the time for sure is a little bit not also here the topic and the target from the customer request. On sapphire, we achieve a result without micro cracks. So the only one we show on our presentation was on the sapphire with the green laser wavelengths. The others with the infrared.
Great. And if we just stay on you, Benjamin, sorry for keeping you so busy. What is the benefit of the 5-axis lasering in coin design?
But this I could not answer a specific case, because for sure the laser tool had some tolerance. So in Z-axis, the tolerance we normally use in our system is 200 microns. So means if the surface is not flat and you have a shape between the Z-axis, to jump between the maximum Z and the minimum Z, and it's the ratio is more than 200 micron, for sure to apply a bitmap file into a 3D shape, we could focus and we could follow the shape with a less resolution of 200 micron. So the target is for sure to follow the shape with our file.
Perfect. Thanks, Benjamin. Thomas, would you take the next question?
We have another one for Platit from Mr. or Mrs. Anonymous. You discussed a plasma etching stage during the PVD process. What is your pre-cleaning process to remove polishing compounds prior to the PVD coating?
Yeah, thank you for the question. So we supply different cleaning solutions, but basically all of them work very similar. You have multiple baths, either within one closed system or several open systems. And you have an ultrasound and washing chemical-based solution here in both cases. For the closed system, which is particularly nice, you have the advantage that you also have corrosion inhibitor and drying process within the same cleaning process, meaning that when the washing cycle is finished, your coin stamps get perfectly dried. You can store them in there or take them out. Then they're ready for coat.
Okay, so Yuri, you are saying that that process is typically done as a pre-process outside the PVD coating machine. Is that correct?
Yes, exactly. That's correct.
Okay, thank you. Dieter?
We have one more on the way for GF Machine Solutions. Do you really use grayscale images for deep engraving? How does the limit of 256 gray cycle colors affect your engraving accuracy?
Absolutely a good question. So seems we are able to explain our software. So in general, there need no any limit of resolution of the grayscale. The way to obtain a grayscale are different, but for sure one of the possibility is to get a 3D file and then to convert to an image. So what is important is that no limitation of resolution of grayscale, but the minimum target is to achieve a 10 micron by pixel. So this is really the value we would like to recommend to our customer. So the minimum resolution by pixel should be something around 10 micron.
Thanks, Benjamin.
Anonymous again. Ingo, this is one for you. Is the CHD media also considered for base metals, for example, for circulation coins?
Absolutely, yes, it is. The combination of the strong chemical resistance, what we show in the study, is suggesting, especially the usage there, because there are typically more oxides present to be need to be removed by chemical energy from the strong pickling, but because of you also want to increase the mechanical force, we may choose then not only the balls, we go to something with more corners, which are the pins or the satellites I just showed. So definitely it is an option for circulation material as well.
Thanks, Ingo.
Ingo, while we have you online, another question for you. Ceramic is known to be brittle. How are you seeing cracked, damaged media? Ceramic media is also available in satellite shape is the other part of the question.
Yeah. Thank you, Dieter. Like I said in the earlier question to Simowitz, yes, there are different shapes, especially the satellites coming on board now. We have the pins, the balls in different diameters to find the right geometry to go into the area you want to finish. With regards to the brittleness or the toughness of the material, this was one of the key issues in the beginning, to find the right formulation between the chemical resistance, the toughness, the mechanical strengths, and the mechanical strength. So the material is capable to handle the pressure in centrifugal finishing machines, especially in combination with high loads of coin blanks. So not only in the small ones for precious metal treatment, also for the larger ones which are considered for circulation. And in order to maintain this, the production step of all the ceramic media having a validation step where the media will be applied to the pressure being present in the process, and only if they pass that pressure test, they will go into the production.
Thanks, Ingo, for this very nice reply and good reply, answering all the questions we had before in that round. Thomas, will you take the next one for Platit?
Yes, for Platit. This comes from Xinyao Li. That's Canada. So Xinyao, if you really have been watching this presentation, you have been starting to be awake from 4 o'clock this morning. Congratulations. That is definitely a very tough one to do. Thanks, Xinyao. Question is raised from Xinyao, Royal Canadian Mint. For Platit, for Yuri, have you tried a coat DLC coating for coining dies, circulation coin dies or precious metal coin dies?
The answer is yes and no. We have tried those coatings, but not in the S-Impulse yet. The thing is that the S-Impulse is capable of doing these coatings, but we are currently developing those recipes for the downscale of this machine, as we have a different chamber size here. But yes, we know how to handle those processes. We know how they work, and we can break this down to the S-Impulse unit. So give us a few more weeks, then this is done. We are working really hard at the moment on this machine.
Yuri, then I'm raising immediately the next one because it's also from Xinyao. Again, what is the temperature during the coating for the chrome nickel? Do you see heater in addition to coating reaction?
So the coating temperature as such is approximately 180 degrees C. We are heating up the chamber before to 200 to 240 degrees C, and then we cool it down. This assists in the degassing procedure. And yes, approximately 180 degrees Celsius it is. We are using the heater in addition. The chamber is temperature controlled, so the heater is driven by a PID controller, and we keep the same temperature throughout the entire process. This also adds to the stability of the process once your substrate is heated through.
Thanks, Yuri, for this answer. Thanks, Xinyao, for raising the questions at the time and with your interest. Dieter, will you take the next one?
Yeah, and then more questions for Yuri, but we give you a little break, and I have one for Spaleck. Ingo, keeping you busy as well. how does the CHD balls or also pins handle edge rimmed blanks?
Yeah, because of the balls, there you need to have the right diameter. So if the rim edge has about 1 millimeter in radius, you will need a 2 millimeter ball, which is available. And especially what we know from the stainless steel media, the satellite geometry, the ball cone, where the rim is nibbling into that area, that's something what we also, the geometry we also want to use with the CHD media, what I just showed. I can do it again. Hopefully you can see the geometry. So this is basically the same bulk material from what we have done in the study, but has the same shape what we are using in the coin blank finishing industry based on stainless steel as a golden standard, was I just described.
Thanks, Ingo. You have been very well prepared for all the questions. Thanks for the answer. Thomas, will you take the next one?
Again, another one for Benjamin from Alexander. Second question. Has the X-ray radiation of a higher power femto been evaluated and proper security measures taken?
Well, it's not too much the power because we integrated the femto technology since 6 years now. So the main absolutely carefully and safety procedure to follow in lasers is the wavelength. So to answer to the question, yes, we answer to the safety reason, especially for the green laser. And if need, I can send the specific class 1 protection we apply.
Super, thank you very much, Benjamin. It seems there is an ongoing dialogue between GF Machining Solutions and Axis, which is also appreciated very much. Thank you, Alexander, for being part of it.
Absolutely.
Now I just have cancelled one question by mistake because we cancelled the question both at the same time. So we take another one then.
You got to forgive us. We need to exercise a little bit more.
We have the very good and valid questions again. Platit, why we change a little bit from Benjamin now to give him a break to Platit. For Platit, congrats to the solid presentation. What makes your system special, really special, and what are the unique selling points?
Okay, so thank you for your congrats. Well, what makes the system special and what we definitely took most care about in the development processes are two things. One is surface quality, because this is the most important for you, for your end product. And the other thing is the user friendliness of the machine, because usually when you work with PVD equipment, you need some expertise. There's a lot of things to take care about. And all this is not the case for the S-Impulse, as we reduced it really down to the essence, what we need to achieve with the perfect coating on your end product. For me, this is definitely a unique selling point, because when you get this machine in-house and start working with it, you instantaneously get familiar with it. And yeah, for me, these are the two most important points here.
I feel that your presentation got a lot of attention, and not only that this is your first presentation in the technical forum. There are many questions on that, and the other one, of course, how many different elements can be used to apply more complex coatings than chrome nitride. Are you able to make processes on temperatures below 200 degrees? But I guess you have answered that question already before. On the temperature.
Yeah, so one word to the second sentence, yes, we can go below 200 degrees. And to the first sentence, let's go back. As I already mentioned, the machine is very simple and operates with one simple target. Of course, you can also introduce co-alloy targets, then you have different alloys in your coating.
Thanks, Yuri. Dieter, I remember actually the one you have deleted. I think you wanted Christoph to be out of the game.
No, not me.
Christoph, I recognized what was asked, and the question was, how do you measure high relief?
Okay, the relief is measured. The method is possible for both typical ways to measure the altitude of the relief. It can be focus variation if you go into detail and if you are very accurate in measuring, but this is slow. And you can have the stripe projection if you want to measure fastly. The point is, if you have different edge shapes, the most important and the most tricky thing is to have a reference layer. And this reference layer is put onto the very top surface, so not depending upon the edge. This process can be used for all kind of edges, all shapes of edges, be it a blank or be it a coin.
Christoph, is this a new way of measuring high reliefs? Has it specifically designed to do so, or has this measurement procedure been there earlier also for other good reasons?
Yeah, both stripe projection as well as the focus variation are used since long. The point was, so far there was no standard how to measure a relief and where to start measuring and how to evaluate it. So the interesting thing about our project has been to get a standard and how to measure a coin repeatability always in the same way and get always the same results, one thing. The second thing is to evaluate the results that we received. And the third thing is then to interpret the numbers that we got, whether it is a genuine coin, a good minted coin, a bad minted coin, whether it's a fit or unfit coin, or whether it's a counterfeited, which has to go out of market.
Okay, and Christoph, I have to add one more question is, how do you assure that your thought process of a high relief will not be melting away because everybody thinks that this kind of integration, high relief into the market circulation coin industry can be done at an attractive cost level as well?
Yeah, thank you for that question. That is something, everybody is asking. No, the costs do not have to go up for having a high relief if the minting process is done properly. But it's not only the minting process, it's also a question of the blank, the right blank. And it's also a question of what Ingo was talking about. It's the preparation of the blank before striking. Then you have the coin design, you have the radius, you have the flanks. They have to be in a correct manner. And if you do all this in a good way, you can have high die lives and higher reliefs than you had before. We had one mint that had even higher, they had higher reliefs and higher die lives at the end of those findings.
Sounds like perfect word. Thank you very much, Christoph, for the detailed answer. Rita, are you taking the next one?
Yuri, we have you on stage again, on the virtual stage. Again, congrats from Mr. or Mrs. Anonymous, first of all. Thank you for the presentation. And do you deposit chrome nitride coatings directly, on the coining dies, or you may use a thin layer of chrome before chrome nitride layer?
You can do actually both. That's not a problem. So the standard recipe comes without the pure chromium adhesion layer. But if you want or insist, or your process requires that, we can also deposit a chromium adhesion layer. That's no problem.
Wonderful. So this short answer is crying for the last question for you as well.
Okay. Again, Yuri, for you. It's a combined question. What would be the typical layer thickness of the coating? And second, for the die size of 30 by 40 millimeter, how many dies can you coat introduced?
Okay, let me answer the second question first, because that's very quick to answer. On this size, you have approximately 12 to 18 stamps in one batch. This depends also on the upper section of your stamp, as this is wider in diameter usually than the lower stamp side, which is engraved, but approximately 12 to 18. And to your first question, a typical layer thickness for a chromium nitride is in the order of 2 to 3 micrometers. If you work with a chromium nitride and a DLC, which is then a DLC2, which is then a combined process, you have approximately 1.5 micron of chromium nitride topped with 1.5 micron of DLC2. If you work with a titanium diboride, then you are more in the order of 1 to 1.5 micrometers, but maximum 3, not more.
Yuri, thank you very much. I wished I would have understood 100%, but I think I need an extra lesson, extra course from yourself directly to really involve and inhale what you have said.
You're always welcome to visit us in Switzerland, no problem.
Yuri, that will happen for sure. We will consider to come and do next time the preparation at your area in the wonderful Switzerland.
Looking forward to that.
Super. Gentlemen, this is the time typically where Dieter goes off his chair on the stage and says, let's go for a coffee break. That will not happen this time because the regulations are not allowing us to do so. Nevertheless, it still means that we are finishing the first Q&A from the virtual session, and this means that we can let you go in peace. And at the same time, I think Dieter and I would like to do this. Well done, wonderful preparation. Not so easy to do what you did in this short time and put things together, and I'm sure everybody, including ourselves, would do things maybe slightly differently, slightly optimized the next time, but we all will have a second chance for sure in our life. For the reasons known to everybody, this is not possible. Nevertheless, we have them now live with us to be able to raise all the questions and have them answered by the experts. Will you raise the first question, Dieter?
Yeah, well, welcome back, friends. Hope you had a nice afternoon or whatever time zone you are, and you're doing well. Great to see you all and to have you back on the virtual stage for the now following Q&A sessions. And as mentioned before, we had about 70 active participants, and the number of questions on the Q&A is full loaded on for a nicely Q&A session we will have now. Yuri, are you ready for the first one? This is on top. How many different elements can be used to apply more complex coatings than CERN or chrome nitride? Are you able to make processes on temperatures below 200 degrees Celsius?
Thank you for the question. I hope you can hear me well.
Yes.
First of all, the S-Impulse is designed in a way that you have a single target in your chamber. This means that you cannot mix different alloying elements from different targets. However, you can work with a pure metal target or a pre-alloy target. That's possible. And from that perspective, you have a relatively large variety of coatings available. As I said in my presentation, we start with a chromium nitride, which is a very basic but already very good coating. But you can also think about our metals and metal compounds, mixtures of aluminum and chromium, or yeah, also purely ceramic targets like the titanium diborite. So there's a variety. And just to maybe add something to your question, if you want to have a different coating structure, again, you cannot use different targets in one process, but you can, of course, always work with a nitride and a metal layer and start stacking those. This can have very beneficial effects on your tool life.
Thanks, Yuri. The second part of the question is about the temperatures, the process temperatures below 200 degrees Celsius.
Yes, that's not a problem. Usually we start with a heating process that takes us up to 240 degrees to degas your stamps. But then during the process, we can go down to 180. That's absolutely no problem.
Wonderful. Thanks, Yuri. Are you taking the next one?
I'm taking the next one. I'm mixing it up actually just to make sure that Yuri can start breathing again before the next question will be asked to him. Patrick Grimmy from Wertli is also awake. Lovely Switzerland. Patrick, I know that you've been listening to the first session this morning as well. You will be double charged with double gin and tonic to Dieter and myself, but I'm reading the question to Christoph Frenz. Christoph, for you. What is the typical range of relief applied on the circulation and precious metal coins? Is there any certain relation diameter versus thickness versus relief?
Okay, thank you for the question. We face a huge difference in the relief height. It starts in very low cases with 6 micron, and for circulation, it goes up to 25 micron in Switzerland. So yeah, Switzerland is they manufacture presently the nicest reliefs. With the diameter and the relationship, this question can't be answered directly because it's always a question of how thick the material is and also which material is used. So this would be a matrix, what would take a little bit longer to explain.
Thank you very much, Christoph. Dieter, next question for you.
Yes, Yuri, I guess you're back and prepared for the next questions, which are coming for you. Brad Everton from the Royal Canadian Mint in Winnipeg, welcome to this session and to the question. And this is not a technical one. I'm not sure whether you want to take it or you just sent him a quotation for you, Yuri. What is the price of a machine?
This is actually something which I will skip because I'm not going to talk about prices here in this session. We agreed on that here in-house. However, if you have questions about that, feel free to contact us.
Well, I can give you the link to Brad, and you can easily get in touch with him. Brad, thanks for that one. But there's another one, a technical question for you, Yuri. You have discussed the plasma etching stage during the PVD process. What is your pre-cleaning process to remove polishing compounds prior to PVD coating?
Okay, so before we put the coin stamp in the coating chamber, we have to remove any polishing paste, any dirt and debris that came from any pre-process steps. And this happens in an external machine. And basically we offer 2 solutions here. One is a solution with open baths, ultrasound, different fluids to remove different types of compounds. The other one is a closed solution where you basically take the coin stamp, put it in a special holder, put it in this machine, and the entire cleaning, or let's say rinsing, and also drying process is done automatically in this closed system.
Thanks, Yuri.
Thanks, Yuri.
Thanks, Yuri. Next.
Yeah, I will take the next one. The next one is actually coming from Torbjørn Hansen from Norway, who is also with us. Thank you very much, Torbjørn, being part of it. You are always also appreciated on the mic when we were in Berlin. The question is to Platit, to Yuri. Yuri, what is your experience of coating laser frosted relief so you do not have the problem that the gold and silver don't or doesn't weld to the frosted relief?
Well, we have ran tests with different mints worldwide. If we start coating different structures, we, at least in all cases, see a beneficial effect of the nitride coating on our compared to a hard chrome. And there's a good chance that if you work with a titanium diboride, this effect is extended even further. So, but there's for sure some more room to look into performance of tools. So if you're interested in running tests with us, let us know, and then we can definitely try that.
Makes sense, Yuri. Confirming results or doubts is, I think, what we all are into. So thank you for that offer, Dieter.
Ingo, are you ready for the next one? This is for
Absolutely,
you.
Dieter.
The CHD material also considered for base metals circulation blanks.
Yes,
Is it?
definitely it is. Especially the chemical resistance is suggesting this, because typically in the circulation business you have strong oxides which you need to be pickled away with some robust chemicals. So from that point of view it is suitable, and also because we are now having alternatively to the balls, which are a bit too gentle from the geometry. We also have the satellites available, which I show now to you in the camera. That will definitely be the media of choice for circulation material, because it has the same shape, and especially the rim of the satellite is capable to clean out the rim area of the circulation blanks. So it's a definitely yes.
Thanks, Ingo. Thomas?
Yep, the next one is again for Christoph, Constitute. Christoph, are you using technology in coin validating systems for distinguishing between genuine and counterfeit coins?
Yes. So the tests we have run have been on machinery, especially we tested different. We started with Zeiss, Wert, Alicona. We had good results with Alicona. And for circulation coins and stripe projection, so whenever it shall be fast, the tests were run on machines from Spaleck with Induvis software.
Thank you, Christoph. Another one, Dieter.
This is now for GF Solutions. Thank you, a great learning session. The comment was here from Steve. Steve G. Looks like it's Steve Gregory, yeah?
We think so.
from the Royal Mint. So welcome, Steve. This is coin die orientated, but are you able to directly cut precious metals, particularly aluminium or AU, please? Thanks in advance for the answer.
Sorry, I did not understand really the question. You mean cutting?
No, the question was, this is a coin die orientated, but are you able to directly cut precious metals, particularly?
Good question. I will say we have different technologies in our portfolio. Honestly, I don't have direct experience, to be honest. So technically, if I think about the material and the request, should be possible. But I did not have any direct experience at the moment. So I prefer to answer transparently that the customer should come back to us in case of.
Or could be another trial case for you. I'll give you the contacts of Steve, and you keep in touch with him to answer that one.
Absolutely.
Perhaps in a later presentation in the technical forum. Yeah, of course. Thomas.
Yeah. Thank you very much. The next question is for Yuri again. 18 tool capacity seems small compared to other systems. Is there any benefit of smaller batches?
Yes, there is a benefit of smaller batches, because in the smaller chamber, for you it's easier to maintain and keep clean, and maintenance and cleanliness of the machine is key for having perfect surfaces. Secondly, remember that the batch times in this machine are relatively short. Usually in standard PVD processes, we have batch times in the order of 6 to 8 hours. And in this machine, it's only 4, so it's approximately half. So from that perspective, your productivity is still quite good.
Okay, so Yuri, are you saying smaller batches are resulting in more precise coating results?
If you look at the loading of the tool, I would say yes, because the orientation of a coin stamp in this machine is so precise. Every stamp sees the same surface of the target, and hence your coating is the same over the entire diameter. You have no variation over the stamp surfaces. And that's a big benefit in terms of precision of the stamp.
Understood. Thanks, Yuri.
Christoph, for you, a question from Rob. Why was the decision to go from the top of the relief rather than the surface plane? Usually heights would be taken from plane 0. This is what Robert is interested in.
Yes, to be honest, we started from 0. We started from the ground of the coin, but we found that there is no repeatability. That was not so accurate as when going from top to the lower. So when measuring the relief, we need a reference layer, and this reference layer we have put on top of the edge. And whatever the shape at the edge is, you can put in a layer, and if you go down from this layer, you will have, if you measure on Monday, Tuesday, Wednesday, all the days, you will have the same results. And this is something that we wanted to achieve, to have a repeatability and that we can evaluate precisely and always with the same evaluation coins. So that is possible better with the reference layer from top downwards.
Thanks, Christoph. Thomas, are you taking the one from Italy?
Yes, Paolo Mascioli. Thank you, Paolo, for being part of this session B of the first session. Paolo is from the Italian Mint and has a question for Platit. In case of a chrome nickels decoating, are you sure we won't have any hexavalent chromium at all?
I am very sure that you have hexavalent chromium when you're decoating chromium nitride. But and that's the major advantage if you compare to any hard plating processes. The amounts are very small because here in the PVD process and also in the decoating process, you're not dealing with large amounts of chemicals. We're talking here about low quantities in the lower liter regime compared to tens or even hundreds of liters for hard plating processes. So yes, you have hexavalent chromium, but in very small amounts, and our decoating solutions are built in a safe way that you are not getting in contact with any evaporized media.
Thanks, Yuri. Paolo, I hope this will answer your question. Dieter will raise the next one.
Ingo, you have some business opportunities at the Royal Canadian Mint, it looks like. The next question for you, can you comment on the wear of CHD media? Do you have a rough estimate on how much longer would you expect the CHD to last compared to the 316 LSS? You have the answer, I'm sure.
Yeah, thank you, Dieter. There is a combination. Wear is a function of mechanical wear and chemical wear. So we have data from the field where CHD media, the ceramic bowls, are used in precious metal production in a 60-liter bowl for more than a year. And we could not measure, or the only wear we could measure was less than 0.1 millimeter in that 1 year in production. If you compare this from the mechanical point of view, that might be similar to the stainless steel, but the chemical attack is the vulnerable spot of the stainless steel. If you use strong chemicals like we just saw in the study, you will solve the chrome and nickel, which are part of the alloy, and this will end up in wear of the surface like we saw in the pictures, and finally also will end up in the wastewater. And if you using the wastewater and send it to the public drain, chromium is a very sensitive parameter. So from that point of view, that's another benefit for the ceramic, because first, there is no chromium in the material composition, and secondly, as a consequence out of this, you will not emit any chromium ions into the wastewater.
Thanks, Ingo, for that one. Yeah. Are you taking the next one?
Yes, Benjamin. Jorben is hitting you with another question. Jorben Hansen from Norway. Benjamin, you're talking about the production of commemorative dies. How about the production of master dies for hobbing circulating dies?
So I will say, yeah, it's a good question. We have done some experience. It's interesting to share maybe some results separately, but for sure our laser and our machine could achieve an excellent result on such application.
Yeah. Are you saying, Benjamin, you are able to laser finish the dies prior to hobbing? I think that was the question. Is that correct?
Yes, correct,
Okay.
correct. We did for, we are in Swiss, and we did some tests on different markets, especially for the watch industry, and it works properly. So I do not know exactly the request coming from our potential customer, but we did some nice, absolutely nice result for watch industry.
Thank you very much for the explanation, Benjamin.
Benjamin, no way for you to go to the relax mode. Another question for you from Shenyao Li from the Royal Canadian Mint. Would you please compare picosec and femtosec lasers in terms of processing time, heating, affected zone, etc.? Well, you don't have another 12 minutes to answer that question, but could you give a brief response to Shenyao, please?
Yes, absolutely. So briefly, I can answer that the femto is totally without burr. So it's called the cold laser in terms of approach. So the big difference you could achieve, especially on some material, is that the engraving or the job you will do with the femto is totally free of burr. So this is the main difference. Then in terms of power, for sure, the 20 watt femto FlexiPulse offer a wide range of parameters you can select. And as you know, a femto can work with a nano parameter and pico parameter. That is not possible with a picosecond laser.
Thanks, Benjamin. Thomas, are you taking the next one for Christoph?
Christoph, I think this question is also about, sorry, this is changing. Yes, now I can see the question. Christoph, are you comparing any data to the original CAD design? I think this is referring towards measurement.
Okay, I didn't get the question fully. If I understand right, comparing to the original CAD data, in design-wise, we changed the curvatures and the flanks. And we also changed their design to bring the relief up. Does this match the question?
Christoph, we don't know exactly because this is Mr. or Mrs. Anonymous, but maybe the person who has raised the question can go a little bit more in detail or contact you directly. I'm sure that is also preferred from yourself.
Yeah.
Dieter.
Shenyao has been pushed forward. He has a lot of friends in the minting community, and this is another question for Ingo. Ingo, have you done any cost or benefit analysis of using ceramic media? Thanks in advance for the question. for the answer.
Typically, this is done by our customers, and it's always price and benefit, or let's say return on investment. This is what it is. Because of the nature of the high performance ceramic, the price for the stuff is on a higher level, but this is the payback what it's counting afterwards. And like we said, the performance on the blank surface itself, the durability, and I stress it one more time, the chemical resistance is giving that trade-off, and justifying the usage is kind of an investment rather than being a consumable.
Perfect. Thanks, Ingo.
Thanks, Ingo. We have another one from Kyle Simpson, also from the Royal Canadian Mint. Ingo, is there any concern with the trace CHD media contamination on precious metal blanks or coins?
Yeah, because we couldn't detect the wear. But on the other hand, there is always a little bit of wear particles. There's in the technology, there's no wear. But the level what we could detect so far was below the measurement traceability values. So from that point of view, we had no negative observations.
Thank you, Ingo. I would also confirm that when the studies were carried out, and we have quite a number of people being interested in this media, we can say, Ingo, if you agree with what I'm saying, that the result and the research was done to find anything on the surface as a leftover on a blank, like also little particles, which is sometimes left over from the stainless steel media, that has not been confirmed. Is that correct, Ingo?
This is correct. We did microscope analysis of all the surfaces, and so on that level, 200 times microscope magnitude, we could not find any visible things. What you sometimes see with stainless when chops of material or flakes from material are falling off the stainless because of the wear and tear of the surface. That has not been observed neither on the blank or on any media, because this is the negative basically of the particle you find on potentially on the blank.
Thanks for the question, Kyle. Thanks for the answer, Ingo.
Christoph, ready for the next one. When you look at height reliefs with straight edges, do you see that more complex relief designs are possible with high relief over the low reliefs?
Yes, it's a good question. The point is that in the past years, nickel-plated steel coins were worldwide winning field, and with the hard surface of nickel, the quality and the relief of the coins went down. And it is possible to have this in two different or even in three different altitudes because of, let me say, a complete change or improvement of the production process. So to achieve the higher relief, we started with the blank, with annealing, and we went on with the curvatures and the designs. And also by what Ingo was saying, we were thinking of how to improve the polishing of the dies to reduce the friction on the surface, and by that we could enlarge the reliefs. And yes, it is possible to have that in different altitudes.
Thanks, Christoph. Thomas?
Benjamin, as a green laser has a narrower beam than the red one, it seems suitable for minting engravings. Why do you think it is better, the red one for the engraving steel?
So honestly, for engraving steel, the best one is the infrared laser, because you could achieve a wide range of parameters. The power compared to the slice remove will be better and efficient in terms of quality and the speed. The green is really interesting on fragile material. So especially for glass, sapphire, diamond, other kind of material. So I will suggest for engraving steel, the femto infrared 40 watt will improve the speed and achieve a good quality on steel. Not green necessary.
Thank you, Benjamin.
Christoph, looks like there will be a great friendship between Tjurpe Hansen and yourself with the next questions which are on the table. For you, you mentioned high relief on circulation coins. Do you mean only a sharp contour of the design or to the table, or do you mean a really high relief?
A really high relief. The high relief makes the difference. And we have seen from if the coin shall last long, it is important that we called it a security area from the edge to the first part of the relief. That has to be especially high. So it's not only the question of the flooring, it's the question of the complete hay in relationship also to the rimmed edge.
Thanks, Christoph, for that reply. And there's another one. Are you taking that?
I will. Torbjörn again. Example of a high relief in Norwegian 10 kroner from 1983, diameter 24 millimeter is 0.55 millimeter. Are you considering this as a high relief as well?
Yes, yes. This is something today we no longer see reliefs like this. I very much like this and appreciate this because if you look at that coin, it looks very valuable and it looks worth something. The higher the relief is, you can make some testings. The higher the relief is, the more it looks to be something worthy. And I think in our times, I think inflation will come after the COVID situation. Inflation will come, and then it is important to give the people the feeling our coins are valuable, and that can be done with coins like you had in Norway. That was a very nice one.
Thank you, Christoph.
Benjamin, you're back on the floor again. Are the shown samples produced with the green laser, and is this one of the reasons why the process took so long?
I will say this question can give me the opportunity to explain a little bit. So our GF femtoflexible laser had the possibility to switch from one wavelength to the second. The switch of these two wavelengths is less than 2 seconds. So I would say the example we share with you during this event was only to explain the capability of our laser system to achieve different material, but especially looking only on the details and the quality. The time, in some cases, we did some very nice combination of, I would say, engraving between green and red, and the time compared to what we show with to you could be cut on 3x3 easily. But for sure, you should find a compromise between the quality and the details reproduction you want to achieve. Let's say that the target of this session with you was to put in advance the quality. So if you compare the RA on the surface and the detail reproduction, this was the main topic we would like to put in advance. Another time.
Thanks, Benjamin. For Spaleck, the next
For Spaleck, I will take this one from an unknown person. Ingo, is there any difference in weight per liter from ceramic compared to stainless steel media?
Yes, it's about 20% lighter. Stainless steel media typically has a weight of 5 kilogram per liter. Ceramic high definition has 4 kilogram per liter, 20% less. This is especially beneficial if you want to reduce, or let's say if you don't want to have such an intensive orange peel, what you sometimes get from the stainless steel media. You just can swap to the CHD, and with the same parameters, because of less weight, you get less orange peel. If you only have the stainless steel, you have to mix. Typically, people softening the satellites with balls. This is no longer necessary. You can directly swap to the alternative material.
Thanks, Ingo.
Okay. Thanks, Ingo, and thanks to Aurelio for the compliments, and all your feedback is highly appreciated. And please go on and continue giving us your valued feedback for the next sessions. So thanks to Aurelio and also for the other comment on that. Coming back to the questions for Spaleck now, from Turban, one more from Turban's 30 years experience. This media have made the blank finishing to a new level. The surface is a lot better for production of all qualities. So that looks, it's not a question, this is a statement. Huh?
It's a wonderful statement. Thank you, Torbjörn, and looking forward to see you again to give you a beer.
Looks like it, Ingo. Thank you very much. I don't take the comment, I just take the question. Ingo, it's another one for you, if you're ready to answer that. What do you mean by height scratches? Would you please compare ceramic pins and satellites? Which ones are better for what kind of material? Blanks question mark.
Pins, okay, yes, okay, no. The height scratches, if you have micro scratches on the surface, polishing is basically cold forming the microscope layer of the blank. If you have a deep scratch, maybe less deeper than 0.2 millimeter, there's no media in the world to hide that, to heal that little scratch. But if you have micro scratches, maybe from transportation or from blanks laying on each other, the media and the weight of the media is forming a new surface while rolling on the surface or applying pressure on the surface. There is more pressure if you have more edges, basically the rim of a satellite or the rim of a pin will some kind of apply the corner, will apply the edge, will apply more pressure, point pressure on the surface rather than a bowl. So if you have micro scratches, media with edges are capable, because of that higher pressure at the point, to eliminate them. Hopefully that answers the question.
Yeah, I think so, Ingo. Gentlemen, thank you very much. I'm just reading the two comments, which are not questions anymore, from Patrick and Steve. Patrick, Steve, thank you very much for the positive attitude you are taking into the panel, onto the screen. That's really a support we are very thankful about. This will conclude the Q&A. Christoph, Benjamin, Jury, Ingo, thank you very much for the second time participation today. The questions were not less, there were even more. This is the time for you to go and have whatever you would like at the time of the day. Thank you very much for being part of it.
I would love to say that let's go to a get together. But we have to postpone that for a little bit time. And these actually were entertaining entertaining 90 minutes for all of us. A very new experience for a virtual technical forum session, and we are very happy that you joined us actively. Your valued feedback is always welcome. You are, of course, invited to participate also in the following sessions. The next one will be in March.
Yeah, thanks. If you, dear audience, if you found the presentations interesting, if you would like to see them again for doubts or for confirming, or whether you have missed part of them, why don't you go on the World Money Fair website and look at the YouTube channel to see them again if you want so, yourself or maybe also your colleagues. This is also the right time to say thank you to Brandstorm, who has really made it possible to be here in this studio, to do the streaming and to have the technical background, which just worked perfectly. That definitely is also worth a round of applause, which we have done on stage typically. At the same time, we have to thank the headquarters in Berlin to be the head organizers of the technical forum. If you like this and you would like to follow the next sessions, which are 2, 3, and 4, the next session will be held on 25th of March. We will again do it at 10 o'clock and 4 o'clock in the afternoon. And the presenters will be the Royal Canadian Mint, Artasen, Innercode, and Tecaprint as a combination. And we would be happy to see you at that session again with the same enthusiasm.
Yes, and you're very welcome to join us. And if you did like this session, please tell your industry associates about it. Free of charge registration on the website is possible at any time. Your valued feedback is highly appreciated. Please give us your feedback and your comments, also possible on the website. And we are happy to welcome additional auditors during the coming sessions in March, April, and in May. Most of the time you will meet us on the last Thursday of the month, usually the day for the technical forum. And I'm sure, Thomas, after the experience of the first session, we really can't wait to talk to our friends at Artasen and Royal Canadian Mint and Innercode and Tecaprint for their presentations and for their contribution. And we will happy to support and looking forward to welcome you again on the March 25th.
Time to say goodbye. Thank you very much for being part of it.
Thanks a lot and goodbye. Take care.
We are having a gin and tonic now.
And keep social distance.